All right, so today we're going to talk about slope and rate of change. We have two new vocabulary words. The first one is slope. The next one is a y-intercept. So let's talk about slope first. Slope is the rate of change in a relationship. The rate of change. How fast or how slow, how big or how small something changes. On a graph of a linear relationship, the slope describes the steepness of a line. What does steepness mean? Yes?
Going down.
It could be going down. It could also be going up. It would determine, like, let's think if you're thinking of a road and it's really, really steep, the line is almost, it's closer to being up and down, right? Vertical. But if it's not steep, it's kind of almost a little more leveled out. So it'd be how steep the line is. Like how fast or how slow that rate of change occurs. Also, slope is defined as the variable m. We're not going to need to use that variable just yet, but I wanted to include it in the notes, because when we get to that point, if you look back at slope notes, you'll see that we do label it the variable m. Okay? Today we're just going to worry about counting slope, so we won't be using that variable just yet. All right, the y-intercept. The y-intercept is where the graph of a line crosses the y-axis. So when you have a line at the point where it intersects or intercepts, where it crosses that y-axis, is called the y-intercept. So if the y-intercept is called what happens when it crosses the y-axis, what do you think, what is it called when it crosses the x-axis? X-intercept, yeah? But for slope, we're going to be dealing with specifically the y-intercept. All right, so let's figure out how we count slope. How do we find slope when we're given a graph? To find the value of slope on a graph, you find the ratio of the vertical change, so up and down, and we compare it to the horizontal change. So vertical is up and down, horizontal is like left to right. And in terms of slope, we call that comparison of the change, we call that rise over run. We need to know that rise over run. It's super important. Rise first, then run. I'm going to even put a little bubble around it because I know it's super important. Everybody say rise over run. Say it again. Rise over run. All right. When we're finding slope on a graph, we always want to simplify the ratio when possible. And then we need to double check if it has a positive or a negative slope. And I'm going to tell you in just a little bit, when we get a little bit further, how we can tell if a slope is positive or if it's negative. Okay? All right, well, what does this look like in action? In action, here's a graph. Side note, is this graph proportional or non-proportional? How do you know? Yes, it's proportional because the line goes through the origin. All right, so the first thing, when you see a line on a graph, so here's our line, I need to pick any 2 points on the line. I can pick any two that I want, but let's make it easy and pick 2 pretty points. So let's make ourselves a note. Pick 2 pretty points. Any 2 pretty points. On this example, they already kind of picked the pretty points for us, right here and right here. They picked the first pretty point at 3, 4. The next pretty point at ordered pair 6, 8. All right. Then what you're going to do, when you pick that pretty point, remember when in the Pythagorean unit how we had to draw that right triangle? That's what we're going to do here. You can see they drew it for us already. There's our right triangle. Now this is where your rise and run come in. The distance that the rise is the distance that the vertical, how far vertically did I go from this point to get to this point? Vertically straight up, that's what's called our rise. And you're already telling me because you already know how to count it, right? Count the blocks, 1, 2, 3, 4. So our rise of the graph was 4. Now run is going to be your horizontal distance. How far did we have to run to get from this point to this point along the x-axis? 1, 2, 3. Now I'm going to go ahead and tell you this is a positive slope, because I'll show you how we do that on the inside. But it is a positive slope. So to make this, remember we said rise over run, right? I'm literally counting how far did we rise up, that change in y value. How far did we run, the change in the x value. So my slope, I literally write it rise over run. My slope is a positive 4/3. My slope is a positive 4/3. Positive 4/3.
So whatever it was on the graph right there is your answer?
Yes. Whatever we actually counted, that would be our answer. The only difference is if we had a negative slope, then it would be a negative 4/3. And we're going to talk about that right now. All right, let's open it up. Let's open up our notes. I want you to meet my pal Oscar. Oscar likes to go snow skiing. Now, when we read a graph left to right, just like we read a sentence. We start on the left, and we look what's happening as we move to the right. And you can see Oscar, he likes to snow ski. Is he skiing up or down? Up, because the line is going up as we move left to right. So what kind of numbers go up? Positive numbers. So this is called a positive slope. It's a positive slope because Oscar is skiing uphill. Uphill, positive numbers, positive slope. Well, just like positive numbers go up, what kind of numbers go down? So when he skis downhill, that makes it a negative slope. Negative numbers, negative slope, because Oscar is skiing downhill. Downhill. Now, any questions on positives and negatives? All right? But what happens if Oscar's just skiing flat? He's not going up, he's not going down. Is that any fun just to ski flat? That is zero fun, right? Zero slope. You can also think of it with numbers. If positive numbers go up, negative numbers go down, what's right in between positive and negative numbers? Zero, just like being flat is in between going up and going down. So zero slope. But what's happening to Oscar in this picture? But why? He's going straight down. That's kind of like he fell off the cliff, right? What happens if he falls off a cliff? He's dead, right? So we have Oscar over here laying down. Excuse me. He's laying down. He went splat. If he went splat, he's just a pile of bones, right? I can't identify him. So he is undefined. I cannot identify him. He is undefined. Now, pro tip. This is what happens that I see every year, and it happened to me as a kid too. When you see these special cases of 0 and undefined, you're like, oh, it's 0. Wait, no, is it undefined? Wait, is it 0? You know it's one or the other, but it's hard to figure out which one is which. So can I show y'all a little pro tip that my teacher taught me, and it helped me remember the difference? Maybe it'll help you. Do you see this horizontal line? I can use a highlighter or whatever pen, and I can draw the letter Z for 0. What letter do you think I'm going to make out of the vertical line? For undefined, a U, undefined. Or I could make an N for no slope, either one. 0, undefined, 0, no slope. You make an N or a U. And I promise, guys, I still use it to this day. When I look at a slope, I'm like, oh, that's 0. Oh, that's undefined. Okay, so if it's a tip that helped me, maybe it'll help you. All right, so we have 4 types of slope. What are they? A slope can be positive, negative, 0, or undefined, or 0 or no slope. All right, let's put this aside. We're going to glue it in a minute. Let's look at the practice problems. Oscar took up all my room in my foldables, so the practice problems had to be on a separate page. For those of you online, your page 3 in your file, it's a double page. It's 2 of these together, so you just have to look at one side of the page. All right, so we're going to practice. First thing, what kind of slope is this? Positive, negative, 0, or undefined? Positive. Make yourself a brain note. Remind yourself that it's positive. All right, next we need to pick 2 pretty points. Are there pretty points already here? Let's use them. 4, 2, and 8, 3. All right. What do I do after I pick my 2 pretty points? I need to make my right triangle. So that way I can count my distance, my rise and my run. So if I start, I think it's easiest to start at the lower point. Because when I look at this, the change in vertical, how far did we rise up? How far did we rise up? From here to here, how far did we rise up? 1. I rose up 1. I rose up. Now I have to run to get over to the next point. How many blocks did I run? 1, 2, 3, 4. So the change in the Y value was 1. The change in the X value was 4. Because X goes horizontal, Y goes vertical. And we said it was positive. So my slope is 1/4. That's all there is to counting slope. But what else did my problem ask for? The Y-intercept. Remind me, what is the Y-intercept? Oh, I love how they're looking at notes. The Y-axis. So where does this line cross the Y-axis? At 1. So my Y-intercept is 1. Or if I needed to write it as an ordered pair, how would I write this point as an ordered pair? What? 0, 1. Remember, I start at my origin. I go over 0 and up 1. So we found the slope, 1/4, 1/4. My Y-intercept was at 1. Or at the point 0, 1. All right, let's look at the next graph. What kind of slope? What? Negative. Help your brain out, make a little notes. And I promise, let's go ahead and say my answer to slope is going to be negative. What happens if we don't remember to put the negative? It looks like a positive, and is that right? No, it's not. So help yourself out. I know it's already going to be negative. My answer has to be negative. All right, we need pretty points. Can somebody tell me one pretty point? Yes. Wait a minute. Wait, okay. First, somebody said 2, 6. And the other one? 4, 5. And 6, 4. Which one do we want to do? I can do either. Let's do 6, 4. You'll get the same answer no matter what 2 points you pick. I'm going to do 6, 4. All right, let's make our triangle. Rise over, run. Rise up, run over. All right, so the change in the vertical, change in the Y. How far did we rise up?
2.
I rose up 2. I sure did. Just now. I just now got it. Okay. All right, so my rise was 2. My change in vertical height was 2. What is the change in my horizontal distance, my run? 1, 2, 3, 4. Oh, but what do I need to do here? Can I simplify this? What could I divide by to simplify it?
2.
Divide by 2, divide by 2, still negative 1/2. So if you would have picked the point 4, 5, you just would have got to 1/2 right off the bat without having to simplify. All right, so what's my slope, guys? Negative 1/2. Super important. If this was a test question, would one of my answer choices be positive 1/2? Yes, it would have. So see how important it is to help our brain and remember that it's negative. Do that right off the bat so we don't forget. All right. Any questions on these two? What questions do we have so far? I'm sorry, did you say you had a question? Okay, hold on. What's your question?
I kind of get it. I'm just not fully understanding how to get the certain point.
Oh, the pretty points, what I'm calling pretty points?
Yeah.
Okay, let me blow this up really big. Okay, I blew this up really big. Do you see how this point 4 and 2, it's on like an exact cross of the X and Y coordinates?
Yeah, good.
So that's what I call a pretty point. Do you see if I went like right here, or even if I went to this point right here, I would have to estimate how far up it is. So I don't want to try to estimate because then I can't get an exact answer. So if I put points that match up exactly on those lines, your X and Y coordinate lines, it makes it easier because I know when I'm counting one full block. One full block. Does that help out?
So your full block at the end got you 4, and the point of the triangle got you the 1.
Yes. This side, the X value, the run was 4. So I put 4 for the run. The rise, how far we went up vertically, was just 1 block, so that's where I got the 1. And I literally write it rise over run. Okay? All right, let's look at problem number 3. Question or answer? Okay? No, I'm teaching. All right, let's look at problem number 3. What type... Oh, we didn't do Y-intercept. I am so sorry. Thank you. It's what? It crosses at 7. And if I needed to write that as an ordered pair, what would that be? 0, 7. Good. All right, let's look at the next one. Positive, negative, 0, or undefined. So we just have to write that. I can't get an answer. It is undefined. Absolutely. Now, Y-intercept. If I'm going to put my orange pen on the line, my pink pen is on the Y-axis. Remember, lines have to go straight. Will these ever cross? No. So will it ever cross that Y-axis? No. So there is no Y-intercept. There is none. It will never cross. I can't say 0 because if I said 0, what does that mean? It crosses through 0 at the origin. So I say none. And then I can also help to remember that the letter U for undefined. Or I could make an N for no slope. All right, what about this one? 0. I can make the letter Z. So my slope is literally the number 0. But where does that line cross that Y-axis? -1. So what would its ordered pair be? 0, -1. The reason why I'm having you write both is because you never know. They might make an answer choice with just a number, or they might make it an ordered pair. So we're practicing both. And guys, that's all there is to counting slope on a graph.